We all live at the bottom of this invisible ocean. It's all around us, every single day, but we hardly ever think about it. So today, let's change that. We're going to take a journey straight up through that ocean, Earth's atmosphere. So, let me just start with a question for you. Think about it. What is the only thing, this thin, fragile shield, that protects every single one of us from the total vacuum of space?
Well, you guessed it. It's the atmosphere. It's this incredible blanket of gases, the air we breathe, that's literally hugged to our planet by gravity. It spins right along with us through space, and honestly, without it, life as we know it just wouldn't be a thing. Period.
Okay, so what is this stuff we're breathing all the time? What's the actual recipe for air? Let's break it down.
What's really wild is just how simple this recipe is, for the most part. About 99% of the air around you is just two things. The biggest chunk, over 78%, is nitrogen. Then you've got the stuff we actually need to live, oxygen, clocking in at just under 21%. And that's basically it. Everything else, everything, gets squeezed into that teeny tiny 1%.
But here's the kicker. This is where it gets interesting. As important as nitrogen and oxygen are, and they are, you could make a really strong case that the most important gases for life on Earth are actually hiding in that little 1%. So inside that tiny slice of the pie, you've got the greenhouse gases. Think of things like carbon dioxide. These guys act like a giant invisible blanket for the planet, trapping just enough heat to keep us from turning into a giant popsicle. And you've also got ozone in there, which forms this amazing shield that blocks the sun's most harmful UV rays.
Yeah, this quote just nails it, right? Even though their quantity is tiny, their significance for our weather, our climate, and our very survival is massive. So if you remember one thing, remember this. Don't sleep on the 1%.
All right, so now we know the ingredients. It's time to start our climb. We are going straight up from the ground beneath our feet all the way to the edge of space, one layer at a time.
And check this out. This is going to be our roadmap. See that line zigzagging up? That's the temperature, and we're going to follow it as we travel through all the different layers. So let's start right down here at the bottom. Home sweet home. Okay, first stop, the troposphere. I like to call this the weather maker. If we're sticking with that invisible ocean idea, the troposphere is the busy, churning bottom layer. It's where we are, it's where we live, and it's where pretty much all of our weather happens. So this layer goes up about, 11 miles or so. It's where you'll find all the clouds, the rain, the storms, the whole shebang. If you've ever flown on a plane, you've spent most of your time right here. And just like climbing a mountain, the higher you go in the troposphere, the colder it gets. Simple as that. But get this is nuts. Even though it's the very bottom layer, and one of the thinnest really, the troposphere holds about 75% of the entire mass of the atmosphere. All that air is packed down here at the bottom, thanks to gravity.
Okay, buckle up. We're leaving the world we know, the troposphere, and we're heading up into the upper atmosphere. And trust me, this is where things start to get a little weird.
Right above all that stormy weather, our next stop is a much calmer place, the stratosphere. Now hold on. Remember how it got colder the higher we went? Well, get ready for a plot twist. Here in the stratosphere, it's the total opposite. The higher you go, the warmer it gets. It's called a temperature inversion. So what in the world is going on? Well, remember that 1% we talked about? The secret ingredient is back. It's ozone. The famous ozone layer sits right here in the stratosphere, and its job is basically to eat up the sun's dangerous UV radiation. And when it absorbs all that energy, it heats things up. That's why we get this weird temperature flip. It's literally the Earth's sunscreen, and it's making this whole layer toasty. Okay, let's keep climbing. Next up is the mesosphere. And this layer has maybe the coolest job of all. It's our planet's meteor shield. Yeah, this is where most of those bits of space rock burn up, creating the shooting stars you see in the night sky. Pretty cool, right? And here we go again. The temperature flips back. It starts getting cold again. Really cold. The very top of this layer can drop to minus 100 degrees Celsius. That's colder than minus 140 Fahrenheit. It is, by far, the coldest spot in our entire atmosphere.
We're almost there. We're reaching the top, the final frontier of our atmosphere, the thermosphere, and then, fading out, the exosphere.
Now, the air up here is super, super thin. But it's still got work to do. In the thermosphere, the sun's radiation is so intense, it zaps atoms and creates a layer of charged particles. We call this part the ionosphere, and it's super important because it's what lets us bounce radio waves around the globe. And then, beyond that, you have the exosphere. It's kind of the last breath of our atmosphere, where it just fades away into the emptiness of space.
Wow. So, let's just pause here, at the edge of space, and look back down at the journey we just took.
Think about it. We started in the troposphere, where all the weather is. Then we went through the stratosphere with its ozone sunscreen, up through the mesosphere, our meteor shield, and finally, the thermosphere, bouncing our radio signals. What you realize is that this isn't just a bunch of air. It's a perfect system. Each layer has its own critical job, and they all work together to create this incredible invisible shield that makes all of life possible.